Okay, guys, so we have now understood about negative inductive effect and positive inductive effect and the order of negative inductive effect and positive inductive effect. So now, what about the applications of inductive effect? Okay, applications of inductive effect. Inductive effect, yes. So using this inductive effect, either negative or positive, we can explain, okay, the stability of okay, carbocations, free radicals and carbanions. Okay, we can explain the stability of carbocations, carbanions and free radicals, and using this same inductive effect we can also explain the strength of, okay, strength of acids and bases. We can explain the strength of acids and bases. Well, we will see the stability of carbocations, free radicals and carbanions when I talk about the reaction intermediates. Then and there itself I will use inductive effect in order to explain the stability of carbocations, okay, free radicals and carbanions. Now in this video we will understand the strength of, okay, acids and bases, how to, okay, depict the strength of an acid and how to depict the strength of a base, okay, using, okay, either negative inductive effect or positive inductive effect. So well, before I go and talk about okay, the acidic nature or the basic nature, okay, first we will solve some MCQs, very preliminary MCQs, okay, and then we will take up these concepts. Okay, yes guys, the first question, I have picked these questions from MTG fingerprints. Okay, you can go and refer it there. So this is 41st question of MTG fingerprints. Okay, so the question says inductive effect involves, please read out the options carefully, a direct question. Okay, inductive effect involves displacement of sigma electrons resulting in polarization. If you read the first option itself, you can gauge the answer. Is it not? Our answer is option A. Is that correct? Okay, inductive effect is nothing but the displacement of sigma electrons towards a more electronegative atom. So that is what the option A is telling. But look at option B. Option B is telling, okay, displacement of pi electrons. No. Okay, inductive effect is just the displacement of sigma electrons. It nowhere involves pi electrons. Okay, is it delocalization of sigma electrons? Guys, please remember, displacement is different, delocalization is different. I will explain what exactly is delocalization when I start mesomeric or resonance effect. Okay, so inductive effect is not delocalization. Inductive effect is displacement. What displacement? Partial displacement of sigma electrons. So even this, okay, cannot be the correct answer. How about this delocalization of pi electrons? No, it's not. Okay, our correct answer is option A. Okay, the next question is telling, what is the increasing order of electron donating inductive effect? Electron donating inductive effect means is talking about what? Plus I effect, isn't it? Electron donating inductive effect of alkyl groups. And I have also told you, okay, the inductive effect of hydrogen is always taken as 0. The CH bond, the inductive effect of CH bond is taken as 0. That means hydrogen will exhibit least inductive effect, 0. Okay, got it? So read out the question again. The increasing order of electron donating inductive effect, I told you, okay, this is nothing but the order of plus I effect. Please refer the order of plus I effect. What is the order of plus I effect? CH2 plus greater than NH minus greater than O minus greater than COO minus. Then we have tertiary alkyl groups, then secondary alkyl groups, then primary alkyl groups and methyl group. Okay, so what will be the correct answer for this? Everything is there, a direct question. See, this is, okay, methyl group, this is okay, what is this? A primary alkyl group, and this is a secondary alkyl group. What is C2H5? C2H5 is nothing but CH3CH2, isn't it? A primary alkyl group. What is C3H7? C3H7 is nothing but CH3, okay, CH3H. This is a secondary alkyl group, okay. So obviously secondary alkyl group will have more positive inductive effect than primary alkyl groups, than CH3 group, than hydrogen. So what is the correct answer? Again, the correct answer is option A. Next question, okay, direct question, very simple. Inductive effect of which atom is taken as 0 to compare inductive effect of other atoms? Look at here, okay, we have compared the inductive effect of all of these atoms with respect to hydrogen, relative to hydrogen, and I have told you, okay, now in previously that inductive effect of hydrogen is taken as 0. So what is the correct answer for this? It is option A. Simple? Yes. Yes, next question. The maximum negative inductive effect is exerted by the group. Okay, so which group will exhibit maximum negative inductive effect? Please refer the order of negative inductive effect and tell me which, okay, group exhibits maximum negative inductive effect. What is it? Is it phenyl C6H5? No. Okay, is it OCH3? Okay, we will think about OCH3 later. Is it Cl? Cl comes somewhere here. Okay, is it NO2? Yes, NO2 will exhibit maximum, okay, negative inductive effect when compared to Cl and when compared to phenyl, isn't it? So what is the correct answer? The correct answer is NO2. Clear? Yes. So we solved the most typical questions on inductive effect. Now we will go with the applications of inductive effect. I told you what are the applications of inductive effect. Using inductive effect we can explain the stability of carbocations, carbanions and free radicals. We can explain the strength of acids and bases using inductive effect, isn't it? So I'll go with the second application of inductive effect. What is it? Okay, strength of acids. Strength of acids. Strength of acids. Okay, first of all you should understand what is an acid, okay, and when you're going to say that, okay, acid is going to be strong, and when will you say that an acid is weak? Okay, so that is the strength of acid. Okay, so please understand this point. Yeah, what is an acid? We know all organic acids are weak acids. Okay, all organic acids are weak acids. Note this point, weak acids. Okay, now I have a substance Ha. Okay, when will you say that this is an acid? This is going to be called as an acid only when it donates H plus ions when dissolved in an aqueous solution, isn't it? If the substance Ha donates H plus ion when dissolved in an aqueous solution, we will call the substance as an acid. Okay, simple, no doubts in it. I hope you all aware of all these simple concepts. Okay, but when will you say that? Okay, how do you decide the strength of this acid, whether this acid is strong or whether this acid is weak? The strength of this acid is explained on the stability of its anion. Okay, note this point. The strength of an acid is explained on the stability of its anion. This is nothing but conjugate base. Is that correct or not? This is called as conjugate base. Okay, yes. So if the conjugate base of an acid is more stable, then the acid is going to be a strong acid. If the conjugate base of the acid is less stable, then the acid is going to be a weak acid. Okay, let me quote it here. Okay, see, if the conjugate base of an acid okay, is more stable, okay, more stable, then the acid is going to be a strong acid. It will be a strong acid. Okay, yes. If the conjugate base if the conjugate base, okay, of an acid is less stable, then that acid will be a weak acid. Okay, then that acid will be a weak acid. Got it? So if this anion is more stable, then that acid will be a strong acid. If this anion is less stable, okay, then we say that acid will be a weak acid. So any phenomena, any process that will increase the stability of this conjugate base will increase the acidic nature. Any process or any phenomena which decreases the stability of this conjugate base will decrease the acidic character. Okay, will decrease the acidic character. Okay, simple. Yes, any phenomena which increases the stability of this conjugate base. If the stability of this conjugate base is increased by any means, then the acidic nature will increase. Okay, but if the any phenomena decreases the stability of this conjugate base, then the acidic nature will decrease. That is what the concept is. Got it? Any doubts? Yes. Let me take some examples. Let me take some examples for it to explain whether the given acid is a strong acid or a weak acid. Weak acid. Okay. Say I have, see this, okay, I have acetic acid and chloroacetic acid, CH2Cl, C double bond O, OH. What is this? Acetic acid and chloroacetic acid. When acetic acid is dissolved in water, it gives CH3, C double bond O, O minus and H plus. When chloroacetic acid is dissolved in water in an aqueous solution, it gives chloroacetate ion and what else? H plus ion, isn't it? Now we have to judge. This is also an acid, this is also an acid. Out of these two acids, okay, which is a strong acid and which is a weak acid? You know, I told you, if you want to judge the acidic nature, okay, you should see the stability of its anion. Which is the anion here? This is the anion. Which is the anion here? This is the anion. Now look at, okay, the stability. Please note this point. Yes, okay. Please note these 3 points. First point, okay, neutral species are always stable. Neutral species are always stable. Okay, 1 point. But in our case, both the species are charged. This is an anion, this is also an anion. Okay, isn't it? So the first point says neutral species are always stable. The second point says, okay, obviously if neutral species are stable, then charged species are unstable. Charged species are unstable. Charged species are unstable. Okay, and one more point, if the charge is distributed, okay, then the stability increases. Stability increases. Okay, if the charge is static, okay, it is not moving. The charge present in the molecule is not moving. Okay, it is not getting shifted. Then the stability will be less stable. Okay, obviously charged species are unstable. They are less stable. Okay, but in a charged species, if the charge is distributed among the atoms in the molecule, then the stability will increase. But if the charge, okay, remains on a particular atom and it is not distributed anywhere, then it is going to be less stable. Okay, see, please note this point. Neutral species are always stable. Charged species are unstable. If the charge in the species is delocalized or if it is distributed, okay, between the atoms of the molecule, then the stability is going to increase. But if the charge remains on one particular atom and it is not distributed within the molecule, then the stability will be very less. Okay. Now I have these two molecules, acetic acid and chloroacetic acid. Both of them are acids which are giving H plus ions in an aqueous solution. Now I want to decide which one is a strong acid and which one is a weak acid, wherein I told you if you want to judge the acidic nature, you have to judge the stability of its anion. That means you have to judge the stability of its conjugate base. Now observe the two anions carefully. One is acetate ion and the other one is chloroacetate ion. Among them, which one is stable? Then that is going to be a strong acid. Which one is less stable? That is going to be a weak acid. Can you please tell me which one is a strong acid and which one is a weak acid? See, observe this. In this acetate ion, this carbon is attached to CH3 group. Carbon is attached to CH3 group. Already this is a charged species, already this is unstable. Okay. Now in this already unstable molecule, carbon is attached to alkyl group. I have told you that alkyl groups are electron donating groups. Okay. So this alkyl group, methyl group will start pumping the electrons towards carbon. Carbon will start pumping the electrons towards oxygen. That means electron density on oxygen keeps on increasing. That means it is going to become much more less stable. It is already unstable. Its stability will decrease further. Okay, its stability will decrease further because the carbon is attached to the alkyl group and the alkyl groups are electron releasing groups. So alkyl group is sending the electrons towards carbon and carbon is sending the electrons towards oxygen. The electron density on oxygen is getting increased. That means its stability is decreasing. Stability is decreasing. Yes or no? What effect is it? This is nothing but plus I effect. Plus I effect. Is this correct? But look at this case. In this anion, obviously this is also unstable because it's a charged species. But whether the stability will decrease or increase. Okay, see this carbon is attached to alkyl group and CH2 group is attached to what? Chlorine. We know chlorine is electronegative atom. Chlorine will start pulling the electrons from this carbon. This carbon will start pulling the electrons from this carbon and carbon will start pulling the electrons from oxygen. Okay, that means the negative charge on oxygen keeps on decreasing. When the negative charge on oxygen keeps on decreasing, the stability will increase. Stability will increase. What is this effect? This effect is nothing but negative inductive effect. Okay. So here the anion is less stable. Here the anion is more stable. So which is going to be a strong acid? Well, this is going to be a strong acid. Okay. And this is going to be a weak acid. Weak acid. Okay. Yes. Are we clear? Yes. So guys, I have this question. Which among them is more stable? See, all of them are charged species. Okay, what is this? Fluoroacetate ion, chloroacetate ion, bromoacetate ion and iodoacetate ion. Okay, all of them are charged species and obviously all of them are quite less stable, unstable. Okay, but among them which is more stable? Okay, please do remember the concept. If the charge is distributed, stability will increase. If the charge is more distributed, more will be the stability. If the charge is less distributed, okay, less will be the stability. Correct? Now, see here, this carbon, okay, I can elaborate this as, okay, C double bond O, O minus. This is, okay, again C double bond O, O minus. Okay, C double bond O, O minus. Please pause the video and note down the question. Okay, note the question. Which is more stable? Okay, yes. So is this or this? Which one? Okay, yeah. So here, okay, carbon is attached to carbon and this carbon is attached to fluorine. Here, carbon is attached to chlorine, carbon is attached to bromine and carbon is attached to iodine. Okay, we know the order of negative inductive effect. What is the order of negative inductive effect? Fluorine more than chlorine, more than bromine, more than iodine. Okay, so fluorine will exhibit highest negative inductive effect. That means, okay, fluorine will pull, okay, the electrons more, okay, towards itself than chlorine, than bromine and then iodine. Okay, if chlorine pulls more, okay, electrons towards itself, okay, yes, the negative charge on oxygen will be decreased to a greater extent, and hence the stability will be increased. I hope you got it. Okay, fluorine being most, okay, it is exhibiting most negative inductive effect, and hence it will pull the electrons towards itself to a greater extent, and hence, okay, the electrons, that is the negative charge on oxygen, will decrease. When the negative charge, when the charge decreases, the stability will increase. Hence, what is the correct answer? The correct answer is option A. Yes. Okay. Guys, we'll take these two questions. Okay, again from MTG fingertips. We'll first solve 46th question and then we'll go with the 45th question. See this 46th question. It says, few pairs of molecules are given below. Okay, he has given, okay, 4 pairs of molecules. Okay, which bond of the molecule, which bond of the molecule of the pairs is more polar? Okay, he is asking which bond is more polar. Okay, which bond is more polar? When do you say that the polarity arises? Okay, very first beginning, very first video of our class. Okay, the polarity is produced if there is electronegativity difference, isn't it? Okay, see the first option. Okay, here we have CH bond. Okay, I have told you the inductive effect of CH bond is 0. Okay, how about carbon and bromine? Out of these two, okay, bromine is more electronegative than carbon. So that means bromine will withdraw the shared pair of electrons towards itself. Obviously, bromine will develop partial negative charge, carbon will develop partial positive charge. That means this bond is polar, isn't it? Next, here also in the second option, okay, look at here. So we have carbon and nitrogen bond. Obviously nitrogen is more electronegative than carbon. Well, this bond is also polar, isn't it? Carbon and oxygen, yes, this bond is also polar, but out of oxygen and nitrogen, which one is more electronegative? Oxygen is more electronegative than nitrogen, and therefore I can say this bond is going to be more polar than this. Okay, in the first option, this bond is more polar than this bond. In the second option, this bond is more polar than this bond. Why this bond is more polar than this bond? Because oxygen is more electronegative than nitrogen. As the electronegativity increases, okay, polarity will increase. Understood? Okay, and in the third case, we have CO bond, CS bond. Here, which one is more electronegative? Again, oxygen is more electronegative than sulfur. Therefore, okay, this bond is more polar than this bond. Correct? And in the last option, we have, okay, CCl bond and CBr bond. Here, we know this very well. CCl bond is more polar than CBr bond. So, what is the correct answer? In the first option, CBr, in the second option, COH, in the third option, COH, and in the last option, CCl. So the correct answer is going to be option B, isn't it? The first option is CBr, the second option is CO, the third option is also CO, and the fourth option is CCl. So the correct answer is going to be option B. Yes? Okay. Now, going on to the 45th question. The 45th question says, okay, which one of the following acids would you expect to be the strongest? So we have iodoacetic acid, chloroacetic acid, bromoacetic acid, and fluoroacetic acid. Okay, yes. So let us write the options. Which are those? Okay, we have iodoacetic acid. So from iodoacetic acid, upon losing H plus ion, we will get this ICH2COO minus. And in option B, upon losing H plus ion, we will get Cl, CH2, COO minus. Okay. In option C, upon losing, okay, H plus ion, we will get Br, CH2, COO minus. And in option B, upon losing hydrogen, we will get F, CH2, COO minus. So when do you say, okay, an acid is going to be a strong acid? An acid is going to be a strong acid if its anion is more stable. Out of these anions, which anion is more stable? We know this anion is more stable. Therefore, fluoroacetic acid is going to be a strong acid. Hence, what is the correct option? It is option D. Okay? Yes. Guys, we have one more question. Which is more stable? Okay. This is nitroacetate ion. Okay. This is CH2 double bond CHCOO minus and fluoroacetate ion. So among them, which is more stable? Again, all of them are charged species. Obviously, all of them are quite less stable. But among them, if the charges are distributed within the molecule, the stability will increase, isn't it? Okay, yes, see this. So here carbon is attached to carbon, carbon is attached to nitrogen, NO2, isn't it? Okay, so obviously nitro group is electron withdrawing group. So nitro group will pull the electrons towards itself, this carbon will pull the electrons towards itself, and carbon will pull the electrons from oxygen towards itself. Okay, the negative charge on carbon, okay, if the negative charge or if the positive charge decreases, the stability will increase. So look here, carbon, okay, nitrogen is pulling the electrons from carbon, carbon is pulling the electrons from carbon, carbon will pull the electrons from oxygen. As a result, okay, the negative charge on carbon decreases, isn't it? Here also the same case, okay, yes, here also the same case. Look at here, okay, yes, first consider this fluoroacetate ion, okay, so fluorine is an electron withdrawing group. Fluorine will pull the electrons from carbon, carbon will pull the electrons from carbon, carbon will pull the electrons from oxygen, the negative charge on oxygen decreases, isn't it? Okay, but out of nitro group and fluorine, which is more electron withdrawing? Okay, you have to refer the order of negative inductive effect. Which is more electron withdrawing? Obviously nitro group is more electron withdrawing than fluorine. So what will be the order of stability here? The order of stability here is A is more stable than C, C is more stable than B. Okay, it is a simple question which is based on, okay, the order of negative inductive effect. Okay, if negative inductive effect increases, the charge on oxygen decreases. When the charge on oxygen decreases, the stability will increase. I hope you have understood. Yes, okay, okay. So guys, next series of questions will be from, okay, the order of acidity. Okay, I'll give you some questions. You have to predict which one is a strong acid and which one is a weak acid, and you have to arrange them in the increasing order or decreasing order of acidity. Okay, so before that, please make sure you are aware of this concept. What is it? Say, look here, please note this point. Negative inductive effect will, okay, increase the stability of anion. Will increase the stability of anion. Okay, if the anion becomes more stable, then acidic nature will increase, isn't it? Acidic nature will increase. Whereas positive inductive effect will decrease the stability. Okay, yes, the positive inductive effect will decrease the stability of anion. Okay, if the anion of the acid is less stable, then it is going to be a weak acid, isn't it? Acidity decreases. So note these 2 points. Okay, yes, negative inductive effect increases the stability of the anion. If the anion of the acid is more stable, then it is going to be a strong acid. Positive inductive effect decreases the stability of the anion. If the anion of the acid is less stable, then the acid is going to be a weak acid. So based on this concept, we will solve all other problems now. Okay, yes, so guys, we have these questions. You have to arrange them, okay, in the increasing order of acidity or decreasing order of acidity. Any order is fine. Okay, so, okay, come on. What about the decreasing order of acidity? Look at here. So we have acetic acid, chloroacetic acid, dichloroacetic acid, and, okay, 3 chloropropanoic acid. 3 chloropropanoic acid. So which among them is a strong acid and which among them is a weak acid? I told you, if you want to know the strength of acids, you should be in a position to judge which, okay, group exhibits positive inductive effect and which group exhibits negative inductive effect. If a group is exhibiting negative inductive effect, the acidity will increase. More the number of minus I groups, more the number of minus I groups, more will be the acidity. Okay, more the number of plus I groups, okay, yes, lesser will be the acidity. Lesser will be the acidity. Okay, yes. So now based on this, come on, which is the strong acid and which is the weak acid? Here we have alkyl group, isn't it? Alkyl group will exhibit positive inductive effect. Here we have chlorine will exhibit negative inductive effect. Here we have 2 chlorine atoms. Okay, so that means negative inductive effect will be more in this case. And lastly we have chlorine. This also exhibit negative inductive effect. See this is exhibiting negative inductive effect, this is also exhibiting negative inductive effect. Okay, now you should be in a position. Okay, see I told you that we know that inductive effect decreases upon distance. See, this chlorine is on the second carbon, whereas this chlorine is on the third carbon. As the distance increases, okay, inductive effect decreases, isn't it? That means the negative inductive effect of this chlorine is less than the negative inductive effect of this chlorine. Okay, therefore, what will be the order? The order of this is going to be, okay, C is a strong acid than, okay, yes, B is a strong acid than D is a strong acid than A, isn't it? Okay, A is a weakest acid. Why it's a weakest acid? Because alkyl group, okay, exhibits positive inductive effect. If there is positive inductive effect, the stability of the anion decreases. Okay, that is going to be a weak acid. I hope you understood. Now, with the next question, look at here. See now, observe the options carefully. Okay, here alkyl group, alkyl group, alkyl group. Positive inductive effect, positive inductive effect, positive inductive effect. Okay, how many positive inductive effect here? Here we have 3 positive inductive effects. Here alkyl group, positive inductive effect, positive inductive effect. So how many positive inductive effects? 2 positive inductive effects. Next, okay, here we have one alkyl group. Alkyl group, that means what is it? 1 positive inductive effect. Here one alkyl group, okay, positive inductive effect, isn't it? I told you, okay, as the positive inductive groups increases, acidity will decrease. Okay, yes, so here we have 3 positive inductive groups, that means acidity will be least. Okay, yes, then this, isn't it? So what is the order of acidity? D is more acidic than C is more acidic than B is more acidic than A. Why D is more acidic? Because it exhibits least positive inductive effect. Please go back and look at the order of positive inductive effect. So methyl group exhibits least positive inductive effect, therefore it is going to be a more, okay, it's going to be a strong acid. Okay, I hope it is clear. Yes, thank you.